over the weekend, and I'm going to give these to you in class next week. And I just summarised everything that you need to know for the exam and everything that you need to know from class this week, plus a few little extra things. So I don't know if you're going to be able to see these on here, but I'm going quickly now, okay? And just to help you remember, because when you get to the exam, sometimes you have a lot to remember and you might be feeling a little bit stressed, and you might forget words. So it's really just there as a reminder in case you have any last minute nerves. Alright? So, plate tectonics. Plate tectonics. Here is the world. You'll have a copy of this, so if you can't see it on the screen now, you'll be able to see it when you have a copy of your own. So the Earth is made up of 4 concentric layers. Concentric just means circular, so circular layers. The inside bit here is called the core, inner core. So it's the most central bit, a little bit like an apple, right in the center of the apple. The inner core is made from solid iron and nickel. Okay, so types of metal: solid iron and nickel. The layer on outside of this is the outer core. So you have the inner core and outer core. Outside of this you have the mantle. Mantle. Remember I talked to you about fireplaces in England, that we have fireplaces and we put flowers or photographs or mirrors on top of the mantle. So the mantelpiece. So here is the mantle. And the mantle is made from semi-molten rock. Semi-molten rock. Outside of the mantle is the crust. The crust. And you need to remember that this is relatively, okay, relatively thin. So it's about 20 kilometers. It's thin. Okay, so another word that you might hear is lithosphere. Lithosphere. And this is basically it's a name that we call the crust and the outer mantle. It's the colder layer, okay? We'll come back to that later on. Okay, so one way to remember the 4 layers is to think of the letters I-O, MC. So MC, think of like a DJ, like microphone control. I owe the MC. When you need to give someone money, I owe you money. So I owe MC. I owe the MC money. That might help you, or it might just make things very complicated. So I'll leave that to you. Okay. So the crust is split into pieces, a little bit like a big round jigsaw puzzle. We talked about these jigsaw pieces, jigsaws. Okay, so if you just imagine that the world is like a football and you've stuck a jigsaw puzzle on the outside of it, so the pieces are all next to each other. Thinking about some of the pieces are blue and some of the pieces are green, and this represents the 2 different kinds of plate, the 2 different types of crust, which we'll come to in a minute. Okay, so imagine your football and you've stuck on the outside some pieces. Okay. Obviously, in reality, the pieces of the puzzle are tectonic plates. So every tectonic plate, and they are either oceanic or continental plates. The word, a few of you asked me this question in class, and it's really good for you to remember. Tectonic just means the movement and the structure of the Earth's crust. So tectonic is just talking about the shape and the movement of the Earth's crust. Now, I told you that there are 2 types of tectonic plate. Like your puzzle on the outside of your Earth, blue pieces, green pieces. Alright, it's easy to remember. So the blue pieces of your puzzle are oceanic plates. Oceanics. These are under the sea. Under the sea. So they make up the oceanic crust. The oceanic crust. And the second type are continental, or your green pieces, continental plates. And these are underneath the land, Now, you need to remember the difference between these 2 plates because it really affects how they collide, what happens when they collide, okay? So just remember these things. So there are 2 types of tectonic plate, 2 pieces of the puzzle. And the first one is the oceanic plate, which is thinner, but it's denser, it's heavier, it's made of a much substance. Some of you had a little bit of confusion about this in class, so I'm hoping that this will help you to remember. And the second type of plate is a continental plate. Continental plate. Thicker than an oceanic plate, and it's less dense, so it's lighter. It's lighter, okay? It's not so heavy as the ocean. And they float on top of the mantle. Remember, the mantle was this layer just underneath the crust. So they float on the mantle. And I remember this by thinking about my time in like the Arctic Ocean and like looking at the ice, the way that the ice sits on top of the water, on top of the ocean underneath. And that's pretty much what the plates are like here. So imagine like big blocks of ice and they're on top of the water. Okay. The tectonic plates float on top of the mantle, a little bit like the ice, like sitting on top of the Arctic. The plates are moving. The plates are moving. They are not completely there. They're always moving a little bit. Just like those pieces of ice, they're always moving. And because the mantle, remember this big layer underneath them, the mantle is underneath them. And the plates are moving a few millimeters or centimeters every, so they are always moving. Okay, so why is the mantle moving? Like, why does that happen? Well, the mantle, remember, is made of this semi-molten rock. So it's hot rock, yes? It's hot. And when you have something hot, it's always bubbling and moving, but it's quite thick, okay? So the mantle is made of semi-molten rock, which is heated, so it's warmed up, of radioactive elements inside the Earth's core, this middle bit. Remember I told you in class that the middle of the Earth is radioactive. And because this is radioactive, it gives off heat. And this heat then is transferred then into the mantle. Okay, so the mantle is heated by these radioactive elements. Alright, the heat produces what we call in science a convection current. Convection current. This is quite important to remember and it will help you understand things as we go. I'll come back to this and don't panic. Okay, so this convection current is heating up the mantle of semi-molten rock. Okay, if you think about, I don't know if you like cooking, but if you have a saucepan or if you're melting some chocolate, it's not bubbling and water's much thinner, but it's a lot thicker, this kind of mantle. So imagine you're heating chocolate, and when you heat it, when you're boiling it, it bubbles, and because it's bubbling, like everything is moving around. Okay, so the layers of the Earth's crust, are just all that a convection current is. Okay, so convection current. And I've drawn you a little diagram to help you to remember. I don't know if you can see this. Here we go. So the cool air sinks, and which way? This way. Wait. Hot air is rising. This is the same whether you make a fire or you, put your finger over a candle. Don't do it because it's dangerous. But basically, when you have something, the hot air will always rise. That's why hot air balloons rise, okay? And when they switch off the heat, it rises and cold air sinks. And that's all that's happening under the crust, in the mantle. So the hot air is coming up and the colder air is coming down, okay? And that creates this convection current, this movement. Alright? That's pretty simple. What is a plate boundary? What is a plate boundary? Remember that I told you a plate boundary is also called a plate margin, and you can use either word, it doesn't matter. Okay, so what is a plate boundary? In class I drew a picture of a jigsaw puzzle, because I think this is the easiest way to remember. And where the two pieces of puzzle, where two puzzle pieces join, this is called a plate margin or plate boundary. You can see here. Let's see if I can get the camera there. Okay, so plate boundary. So the boundary or margin is the point where the two plates meet. It's normally at the edge of the lithospheric plates. Okay, so again, this is so the plates are lithospheric, and the boundary or border is where these two. Really complicated, but it's not. If you look at the word lithosphere, the word litho comes from the Greek rocky. Okay, so what's the earth crust? It's made of rocks. Rocky. And sphere is the Greek way of talking about something that is round. Okay, so it just means rocky round. So it rocks the crust on the outside of the planet. So the lithosphere is basically, remember I was telling you about loaves of bread as well, to help you with the Georgian English translation, that the crust is like a loaf of bread, in the middle is soft, and the bit on the outside of the bread we call in England the crust. Okay, so the lithosphere is basically just the crust of the earth, the outside of the earth. It's the coolest part of the earth, and it's made up of the crust and the top part, the top bit of the mantle. Okay, that's all it is. Now, there are three primary types of plate boundary. Three primary types. There are four, but three, but we'll talk about them again now just to help you remember. So, the three plate boundaries, or three plate margins, are constructive, destructive, and conservative. Constructive, destructive, and conservative. This type is constructive, but we also call this a divergent border as well. So constructive or divergent, you can use either word, whichever helps you to remember. Okay, so this is basically just where the plates are moving apart. So constructive, moving apart. Two plates moving apart. Constructive. When the two plates move apart, the magma, this liquid, hot, sticky rock, the magma escapes through the gap between the plates. So here are your two plates, they were together. As they move apart, here is a gap. And from this gap comes this current. This comes up between the gap and escapes. As it comes up between the gap, it meets this cold air here, or whichever it is, which depends on the type of plate. And it comes up, it meets this coldness here, and it turns into plate, a new tectonic plate. So constructive, remember, also called divergent boundary, is where two plates moving apart or diverging. The magma, liquid rock, is escaping through the gap between the plates. And this escaped magma, this magma that's escaped, cools and it forms crustal rocks. Remember the word crust, Earth's crust. And the crustal just comes from the same word, crust. So that are in the crust, basically. Okay, so the magma cools when it reaches the cold. So you've got under the water these mountains forming. But they don't have to be under the sea, it's just one example. Okay. One example of a constructive plate boundary is the Mid-Atlantic Ridge. And you can remember, if you think about the country, this Mid-Atlantic Ridge runs from the north to the south. And as the plates are moving apart, I mean, maybe in 1 million years or 5 million years, Iceland will be two different countries. Who knows? It's coming up. You have this volcano zone. That's why the volcano erupted in Iceland quite recently. And remember, I think I told you a little bit about what happened in Iceland. These volcanoes were erupting because this ash and magma was very, very hot.